What's up, guys? Welcome to part 1 of the Enhanced Input Root Motion add-on mini-series. In today's episode, we are going to start to set up the logic for our character to turn in place. The reason I am doing this as an add-on mini-series is that we are going to change the way the movement works a little bit, and I wanted this to be optional so that if you don't care to add turn in place, you won't need it to follow the rest of the root motion series. The Discord server link is in the video description. You can ask questions about the tutorials. If you are having any issues, that is the best place to go. You can also find a link to the animations used in the tutorial in the description. Do me a favor and hit the like and subscribe for me. There is a 69.5% chance that you watch my videos and aren't subscribed yet, and I want the videos to reach the people needing them the most. Without further ado, let's get into it. So first thing we need to do is open up our character blueprint. So third person blueprints, BP third person character. We need to go ahead and disconnect this camera lock. You don't need to delete it. We may end up using it later, but for now we're going to just go ahead and disconnect that. And then we also need to go to our BP third person character self here at the top. And then we're going to use the controller rotation, so you can just type rotation, and then you want to make sure use desired, so make sure use controller desired rotation is ticked, and then we want to make sure that we're using the controller rotation, y'all. Go ahead and compile that. Make sure that that's working right. So we should be turning with the camera now. That's why we have to set that up to use the yaw. This is when we're turning. We're going to want the animation to turn in place based on the direction that we're looking. So we need to be able to control the character with the turning of the camera at all times. This is the reason why I said that we were doing this as a mini series, because it is going to change it a little bit. You can go ahead and compile and save that. Close that blueprint out. We're not going to need that anymore. And we need to open up our animation blueprint. And let's go to the event graph of that. So we're going to add in our coding for our turn in place. First thing we need to do, let's go ahead and drag this back a little bit. And off of our is valid, we're going to add a sequence. Alright, and then we need to create a function. We're going to call this turn in place. Go ahead and click on this. And we're going to add a input. And this needs to be our BP third person character object reference. Whatever your character blueprint is there, is what you can call that. And then we're just going to name this character reference. Go ahead and compile and save that. Alright, and just in case you haven't yet, let's go ahead and set up a movement category for our variables. So you click on your side input, your forward input, right here where your category is at. You just type in movement here and it'll create a movement category, and then you can just drag those over that movement and it'll add it to that category. Let's see here, that way we can have this kind of cleaned up some. And then we're going to go ahead and create a variable. We're going to change that to a float. And we're going to name this character yaw. And then we also need to create a local variable. Now, that's going to be a float also. We're going to call this one character yaw last tick, parentheses, local. That way we know that this is a local variable. So we get our character yaw that we created, and we're going to set the character yaw last tick local, connect that there, and connect that to our turn in place. And then we're going to drag from our character reference. We're going to get actor rotation. Then right click on the return value. We're going to split the struct pin. And then we're going to set the character yaw. You can hold Alt when you drag that out and let go, and that'll set it automatically. And then we're going to take our return value Z yaw. We're going to connect that to our character yaw. So basically what this is doing, so our local variables, once the function has ran through the whole function, this will be reset. The normal variables are going to save that, so we're basically checking what the last tick from our character yaw was, to get our character yaw, and then this is what sets the actual rotation of the yaw of the character. So now we need to calculate the yaw difference, but we need to create a variable first to set the calculation. So we're going to create another local variable, and that's going to be a float again, and we're going to call this one yaw change over frame parentheses local. So we're going to get the yaw last tick local. We're going to get the yaw change over frame. No, we need to get those, not set those, I'm sorry. So get those, and you can use control, and control will get those. And then we're going to subtract these. So subtract those. All right, and then we need to get our wait a minute here. Okay, no, I see what I did here. So we need to get our character yaw. We need to subtract our character yaw last tick from our character yaw, and that's going to give us our yaw change over the frame. We can just take this, turn this up a little bit. Let's just set this up here. Actually, we can keep that down here. It'll be fine. Go ahead and comment this, and this is calculate yaw difference. All right, and then now we need to set it up so we can only turn in place when we're idle. So we're going to create a branch. So hold B for boy and click. We can connect that branch. We're going to create a new variable, and we're going to call it yaw offset. Root yaw offset, I'm sorry. So root yaw offset. We're going to set that after our branch. We're going to go ahead and duplicate that and connect that to our false as well. All right, so then we need to get our forward and our side input. So hit your movement drop down, go ahead and get your side input, go ahead and get your forward input. This is going to be kind of set up the same way that our camera lock was set up, so that we can only do the turn in place when we're in idle state. So from our forward input, we're going to do not equal. You can just duplicate that and connect your forward and side to each one of those. Get rid of this stupid preview. Sorry about that. My cat just ran across the desk. He wants to be involved today, I guess. From that not equal, we're going to do an or boolean. And move that one down to there, there. And we're going to connect this to our branch condition. Only turn in place when idle. That way we just know what this stuff is. So if we need to go in and change anything, we know where this stuff's all at. So for our true, if this is true, then our root offset's going to remain 0. If this is false, then we need to take our yaw change over frame that we just set the calculation for, and then that root yaw offset that we just made the variable for. We're going to add these together, and then we're going to normalize the axis on this. Normalize axis. That way it gives us the axis of those two added together. And then we're going to take this, and this is going to connect to our root yaw offset. And you can go ahead and compile and save that. That way, if there is an issue, we do have a crash, we do have this stuff saved already. Don't want to run into that issue. So basically right now we've just got it set up to do the calculations for our turn, because we don't want just the character to turn, we also want the capsule to turn. So we got to get these calculations set up. If you've not imported the animations yet, go ahead and do so. Once you get those imported, if you want to open one up, I'm going to just show you guys what I've done here. So basically how we're setting this up is we're using curves to determine our turn. And I'm just going to go ahead, I'm going to go in here just so you guys can kind of see it. We're not going to go over this in this episode. We're going to also do the crouch turn in place. And I figured we'll go ahead and go over that and how to do these curves in that episode. Because we're also going to be doing the aim offset. I'm going to show you guys how to just take whatever idle animation you guys have and make your aim offset off of those. So I just don't want the videos to be too long and there to be too many videos. I kind of want to get this knocked out so that we can kind of move on to other stuff. So in this portion, we're not going to go over setting up the curves. We'll do that for the crouched. So all you'll need to do is just drag those in, import those, and they should be set up for you already for what we need to use them for. So what we're going to do now is off of our root yaw offset here, we're going to set our turning curve. So we need to create another local variable, and that's going to be a float, and we're going to call this, actually no, let's not do that. Let's not do that. We're just going to get curve value. Right click that, and then we'll promote to a local variable. And then we'll call this turning parentheses local close parentheses. And then this is going to hook up to our root yaw offset. Curve name here, this is the curves that are in the animation. So our first one's going to be our turning curve. T turning. Make sure that that's named correctly. And then we're going to check to see if that is less than 0 or greater than 0. I apologize. And then we're going to create a branch, and we're going to connect that greater than into the condition. Move this stuff over, get it cleaned up a little bit. Go ahead and highlight those. We're going to comment. It's going to be our turning curve. And then we're also going to do our distance curve. There we need to let me take a look at my notes real quick. I want to make sure that we do this correctly here. We're creating a lot of variables and stuff, so I just want to make sure that we're doing this in the right order. Yeah, okay, so we need to create a variable, just a normal variable. We're going to call this one distance curve. And then we're going to create another local variable. And this is going to be distance curve last frame local. So we're basically going to do just like we did with our yaw. We need to do the calculations and stuff. So we're going to get our distance curve. We're going to set our distance curve last frame. And we're going to plug our distance curve into that. And then after that, then we are going to get curve value again. Right click, get curve value. Let's go ahead and just change the name on this one. This one's going to be distance curve. Make sure you do the capital C, no space in between distance and curve. And then we're going to set that distance curve variable that we just created. We're going to connect the return value to that. And this is going to be move that up and highlight, comment that one, distance curve. Okay. And then we're going to create a local variable, and we're going to call this negative or positive parentheses local. And we're going to get our root yaw offset, and we're going to use a select float here. We're going to use select float. That way we have an A and a B. Alright, we need to disconnect this because this is actually going to go into our index. So we're going to go off of that, we're going to go greater. No, we don't need a select float. Let's just do a select off of this. There it is. So it should be the select with the 3 bars when you go to it. It should have the kind of fork. So select with just the fork, not the actual function class. That way we get an index with a true or false. And then we're going to take our negative or positive local, and we're going to set that. Connect the return value here. That's going to open up our false and true values. False is going to be 1.0, and our true is going to be negative 1.0. So this is our setting our root offset. So if our root offset is greater than 0, if it's true, it's going to be negative 1. If it's false, it's going to be 1. So this is basically setting just like our root motion. Right is positive 1, left is negative 1. So it's kind of setting it up the same way so it can determine which direction we're going to turn based off of our root yaw offset. Okay, so then we need to get our distance curve last frame local. And we're going to get our distance curve, and we're going to subtract these. Subtract. And then we're going to get, okay, so, and then off of that, you can right click your pin on your subtract here. We're going to promote to a local variable, and we're going to call this one distance curve difference, parentheses, local, close parentheses. We're going to connect that there. All right, and then we need to get our distance curve difference. And then we need to get our negative or positive local. And we're going to multiply these together. So, multiply. And then we're going to get our root yaw offset. We're going to subtract that from the value of the distance curve difference and the negative or positive being multiplied. So okay, and then we're going to set our root yaw offset, and that is going to be our root yaw offset value. And then we're going to make this absolute, so yes, absolute float. And then go ahead and promote to a local variable off of that. And that's going to be our ABS, so absolute root yaw offset local. And then we're going to create another variable, and we're going to call this one max TIP, so max turn in place angle. So from our root yaw offset here, we're going to go ahead and connect these. We're going to create a branch right afterwards. Create a branch there. Connect that. And then from our ABS root yaw offset local, we're going to drag down. We're going to get a greater. We want that to be greater than our max turn in place angle. Okay, and then we're going to drag off here again, and then we're going to subtract. And that's going to be our max turn in place angle again. And then go ahead and promote to a local variable. And we're going to call that yaw to subtract local. Yeah, it's a lot of variables. There's a lot of calculations in this, but once we get this all set up, it's hard to explain. It's easier to see it once it's working, and then we can kind of go over it a little bit more. So then we want to get that yaw to subtract local, and we're going to multiply that. Go ahead and duplicate that multiply. We need 2 of those. Connect that up to both of those. The top one we're going to set to -1.0. Bottom's going to be 1.0. We're going to do another select, so right click and select. And grab your one with the white branches there. Then we're going to grab our root yaw offset. Get your root yaw offset. And we want to make sure that this is greater than 0. We're going to plug that into our index of our select again, like we did in the last one. And then for true, we're going to connect the bottom, which is +1, and the top, we're going to connect the top, which is -1. And then we're going to set our yaw to subtract local. Move this stuff kind of out of the way. Connect that. And then our return value is going to plug into our yaw to subtract local. Then off of our yaw to subtract local, we need to get that root yaw offset again. And we're going to subtract again. We're going to connect our yaw to subtract local to the bottom of our subtract. So we're going to subtract our root yaw offset from our yaw to subtract local. And that's going to give us, that's going to set our root yaw offset. Plug that. Go ahead and compile. and save. And you should see your guy still standing in idle there. So just kind of go over this real slow here. I'm gonna let you guys take a look to make sure that you guys got all this stuff set up the way it needs to be. Let me shrink this down, give it some more space. So we got our turn in place function, has an input of our character reference. So we get our character's yaw. It sets our character yaw last tick. We get our actor rotation to set our yaw for the character yaw. Then we calculate the yaw difference between the last tick and the character yaw. That gives us our yaw change over the frame. And then we determine if we are moving. If we're not moving, then we will be able to turn in place. If we are moving, then we will not be able to set our root yaw offset. So if we're not, we'll be able to set the root yaw offset when we turn. If we are moving, we will not be able to. So to set our root yaw offset, we take our yaw change over frame and our root yaw offset. We add those together, normalize that axis, and that will set our root yaw offset. Then we get our curve value, which is our turning curve in the animation. That's going to set our turning curve local, and if it's greater than 0, then it will move on to our distance curve. If it's false, it will do nothing. Once we move on to our distance curve sets our distant curve last frame, and then we get the curve value, which is named distance curve, and that's going to set our distance curve. Then we get our root yaw offset. If it's greater than 0, sets the negative positive value at 1 or -1. Then we get the distance curve last frame local, subtract that from the distance curve. That gives us our distance curve difference. Then we take our difference curve difference and we multiply that by our negative or positive that was set, so 1 or -1. And then we subtract that from our root yaw offset. And that's going to give us our actual root yaw offset turn. That's going to set that as an absolute value. And then we set that as the absolute root yaw offset. If that is greater than the maximum turn in place angle, then it will go to true. It will then it will subtract the max turn in place angle to set the yaw to subtract. And that's going to take that yaw to subtract, multiply it by our -1 and our 1. So if it's false, it'll multiply it by -1, so it'll turn it to the left. If it's true, it'll multiply it by 1, so it'll turn it to the right. That's only if the root yaw offset is greater than 0. That will set our yaw to subtract. Then we subtract that from our root yaw offset. That gives us our final value for our root yaw offset. I know it's a lot of calculations, kind of difficult to understand. Best thing I could tell you is just make sure everything is set up the exact same way. Once we go in and play, should still be turning and stuff here. We haven't actually initialized the function in the character blueprint, so you should not have any motion yet as far as turning or anything like that. But I think we're going to go ahead and stop here at this point. In the next video, we'll update the animgraph and get the animation set up. That way we can start going through the animations. We've got the calculations, the function's all set up now. So that part of it, we're done as far as setting up the actual code for it to work. We just need to set up the animations and stuff so that the animations actually go through the calculation and turn the character. So hope you guys enjoyed the video. If you have any questions, by all means, hop in the Discord, ask your questions in there. I will make a channel specific for the turn in place. That way we can keep any questions in that section. That way if anybody else has any issues, they can, maybe look through that stuff. They might find that somebody else had the same issue. So I hope you guys enjoyed the video. I appreciate all the support. I hit over 200 subscribers as of this morning. I really appreciate you guys taking time out to come and watch the videos and give me a chance to kind of teach you guys some of this stuff that I figured out. So I will see you guys in the next video. Peace.